Right, guys. I had every intention of being here today, and some things happened with my friend that I need to be with her, and so I'll be back on Friday. Don't forget that your homework from rotation day is due on Friday, and there's that video online that will help guide you through it. For the most part, you guys did great on your rotations, and I appreciate that. Most of you just got 300s for the day. So I do appreciate that and your hard work and your respectfulness to the other teachers. They all said great things about you. Um, you'll need scratch paper, and then you'll have time to work on your practice, and you'll have time to work on your homework due Friday. So we're going to go through this rather quickly, talking about probability. Theoretical probability, that means in theory. So in a perfect world, how likely is something going to happen? And so to figure it out, you put the wanted outcomes divided by the total possibilities. So examples of that would be picking a card from a deck, tossing a coin, spinning a spinner, rolling a number cube. So if I wanted to pick the 8 of diamonds, the chance of that would be 1 out of 52. If I wanted to spin a green, the chance of that would be 1 out of 6. If I wanted to flip a tails, that'd be 1 out of 2. If I wanted to roll a 3, that'd be 1 out of 6. There's two kinds of probabilities, independent events and dependent events. If you're not sure what those mean, go ahead and write those down. So when the outcome of one event does not affect the probability of another event. So if I roll a dice and I flip a coin, the answer on the coin is not affected by the number on the dice. And then dependent events, one event affected by the outcome of another event. So that's like drawing 2 diamonds in a row. Like if I just flip over the top 2 cards, because the probability the second one's a diamond also is changed if the first one's a diamond, because I've already used one of my cards. So that's the difference there, if one affects it or not. And you can think about independent being alone, it doesn't affect it. And dependent depends on the one before. So we're going to talk about these probabilities, if it's independent or dependent, and then we're going to solve them also. So the probability of tossing 4 coins and all 4 landing on heads, they don't depend on each other. So that would be an independent event. The probability of drawing a king from a deck, not replacing it, and then drawing another king. That's what I was talking about on the last example. Because drawing another king depends on if I drew a king the first time or not. Rolling an even number on a cube and tossing a tail on a coin. They don't have effect on one another. Picking a black sock out of a drawer, replacing it, then picking a white sock. They don't depend on one another, because when I put it back, it now has the same probability. Like it's kind of like starting over. So if I replace something, it's independent. If I don't replace it, it's dependent. So it just affects your numbers a little bit. So the probability of tossing 4 coins and all landing on heads. Well, heads is 1 out of 2. Every single time it's 1 out of 2. We multiply all those events together. And then our fractions, we multiply the tops together, we multiply the bottoms. 2 times 2 is 4, times 2 is 8, times 2 is 16. So you have a 1 in 16 chance of that happening. The probability of drawing a king from a deck, there's 4 kings out of 52 cards, times drawing another king. So now there's only 3 left, and there's only 51 cards left. So the probability would be 7 out of whatever 52 times 51 is. 52 times 51. Whoa. 2,000. I'm going to rewrite this. 7 over 2,652. That's the probability of that happening. Rolling an even number on a number cube. Well, there's 3 even numbers and there's 6 numbers. And tossing a tails on a coin. By the way, you can either reduce these fractions before or after you multiply. You will get the same thing. And then pulling a black sock out of a drawer, replacing it, then picking a white sock. We can't do this one because I don't know how many black socks are there and how many total socks there are. So we can't do that numbered one. So what you're going to do is you're going to answer these on your scratch paper, and then later I'll show you the answers. So for now, I'm just going to kind of scroll through them. I'm not really going to talk about them. So just pause it for each question and answer, and then play for the next question. Make your screen bigger. Hope you didn't see the spinner on that last one. Here's your spinner. Can't see this question. Okay. And then, like I said, I'll show you those answers at the end. So Sabrina has a bag of 5 marbles that are identical in size. The bag contains 4 blue marbles and 1 red marble. If Sabrina randomly draws a marble from the bag, replaces it, and then draws another marble, what's the probability she'll first draw a blue and then a red? So there's 4 blue and 1 red, 5 marbles. Whoa. So the probability, so those are all blue, well there's 4 of them out of 5. She replaces it, so there's still 5, and the red is just 1. So that's a 4 out of 25 chance that would happen. Jerry has a CD case that contains 4 country CDs, 1 rock and roll, 2 rap, 3 Tejano. What's the probability? Selects Tejano. Without replacing it, selects rap. So the difference here, which we talked about a little bit ago, 4, 5, 6, 7, 8, 9, 10. I have 10 CDs. The chance of drawing Tejano is 3 out of 10 without replacing it. So now there's only 9 CDs left. And a rap CD, there's 2 of them. So that would be 6 out of 90. And then you can reduce that by dividing everything by 3. Nope. 6. 1 out of 15. That would be your chance of that happening. Okay, so you're going to do another quiz. Oh. Why can't I make this bigger? Okay. Okay, you can see it all now. You can't see that Venn diagram very well. Oh, you still can't see it. Just skip it. You can skip this question. That one says 1, 2, 9, 4, and 5. They're all even, and it's 1, 2, 9, 4, and 5. Okay. So the theoretical probability of flipping a coin would be 1 out of 2 because it's an equal likely event to happen. You're just as equal to get heads as you are tails. But if we were to talk about something we experiment with, like free throws, that'd be experimental probability. And so I can't say what the probability of someone making a free throw is until I have some data to go off of. So experimental probability has to do with how many times it has occurred, so you can predict the next thing, like batting average. So if somebody were to have 20 free throws and he made 12 of them, what's the experimental probability he'll make the next one? You just take how many he did make divided how many he tried or he attempted, and then that would be the probability of it happening again. So I could reduce those both by 4. So it's a 3/5, which is like 60% chance he'll make his next one because that's how he's done in the past. The last type is geometric probability, using shapes to calculate it. So this is a typical one. So if all these squares are the same size, and I have 1, 2, 3, 4, 5, 6, 7, it's a 7 by 7, so there's 49 total squares. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. They're shaded in. So the chance of landing on a shaded in square are 13 out of 49. Or it could be something like this. If I drop a coin into a wishing fountain from above, what are the chances it'll land in the smallest tier? So in this case, I have to look at the area. So the area of this small circle is 1 pi. The area of the big circle is 144 pi. So the chance that it would land in here is 1 pi divided by 144 pi. If I take the area of the shaded region over the area of the whole thing, there's a 1 in 144% chance, or 1 in 144 chance that it would land in that area. So that is all based on your notes. In a second, I'll show you the answers to those quizzes so you can check to see how you did. And if you didn't get something right, go back and look at it. And then you have time to work on the practice sheet, which we'll grade Friday when we get to class. And then you have time to work on your homework, which is due Friday. All right. Thanks, guys.